Hi everyone. In this video we are going to discuss integer data types in Java. Before starts today's session, let us try to recall what have we discussed in our last session. Why do we need to specify data type in Java? What type of the information will be sent to compiler when we declare data type of a variable? Categories in data types of Java. What is the difference between primitive and non-primitive data types? In the last session, clearly we covered what is primitive, what is non-primitive, what are the properties of primitive and non-primitive data types. If you haven't watched, the link of the Java playlist is given in the description box. Please check it out that for better understanding of this video. After watching this video, you will get the knowledge about why Java provides 4 different types of integer data types, what is type mismatch error, what will be happened if we write increment 127 as value of byte variable, how to store octal, hexadecimal and binary literals. What happens if we miss capital L or small l in long literal value? In our last video, already we covered primitive and non-primitive data type properties. In this session, we are going to discuss what are the major categories of the primitive data type. Primitive data types at first step divided into 3 types. Those are numbers, boolean, character. You may get the doubt why Java provides this many different types of the data types. When you are working with your projects or any applications, you may need to save different types of the data. In the real life, some data may be a name of the place, person, thing, or some data may be in the numerical format, some data may be in the true and false format. So on different formats of the data we need to maintain in our application. To handle different types of the values, Java provides different types of the data types. Every data types have their own properties, have their own rules. If you want to work with that particular data type, you need to follow all those rules. See, in the primitive data types, we can store numbers and boolean values, character values. We will discuss about boolean and character later. In this video, we are focusing about numbers. Numbers can be also 2 types. Suppose if you want to store mobile number, that is a number without fractional part, without decimal part. At any cost, mobile number doesn't have any fractional part. Suppose if you want to store height of a person, maybe 5.10, 5.8 and so on, that have a fractional part. So in the real world, the numbers may have fractional part, may not have the fractional part. Depending on this property, numbers also can be of 2 types, integer types and decimal type. We will discuss these decimal types later. Focus here, integer types. In the integer types, again we have 4 categories in Java. Those are byte data type, short data type, int data type and long data type. These are the actual data types which we use in our programs to store the integer value. We are focusing on these 4 data types, byte, short, int, long. See, integers can be used to store a number without fractional part. That is the basic property of integer type. Integer types are the numbers without fractional part as we discussed. Example, hall ticket number, mobile number, etc. Here hall ticket number also may not have the fractional part generally. With the help of the integers, we can store positive values and negative values also. The 4 integer types defined by Java are byte, short, int, long as we have seen just now. you can understand the major difference among the 4 integer data types with help of this image. Byte occupies 1 byte of memory. As the name suggests, it occupies 1 byte of the memory. 1 byte equals to 8 bits. Short data type occupies 2 bytes of memory. Int data type occupies 4 bytes of memory, and a long data type occupies 8 bytes of the memory. So when we move from byte to long, it occupies more memory. So depending on your requirement, you can choose required data type. First one is byte data type. This byte is the smallest data type among all the integer data types, as we have seen just now. With this, we can use memory efficiently because it is smaller than all other integer data types. If you want to store a smaller number, it is suggestible to declare that number as a byte type because you can save the memory. You can utilize the memory efficiently. If you declare as a int type, even though you are storing the small number, unnecessarily the memory will be wasted internally. So it is suggestible to store small numbers with limited size by using the byte data type. The range of values we can store with help of the byte is -128 to +127. Syntax to create byte variable. Byte is a keyword, variable name, assignment, value you want to assign. See the important point. If we try to initialize byte variable with out of range value, it raises type mismatch error. See the example program. In this program, I declared a variable b as byte type and I am assigning the value 128. As we have seen just now, the range of the byte type is -128 to +127. But I am trying to store 128, where 128 is out of range of the byte. In such cases, it raises type mismatch error. Now see the example. Class name, within the main method, declare a variable b as byte type. I am assigning 128. Then I want to print that b value. If I place the mouse at 128, generally the integer value is also called integer literal. Now you can observe type mismatch cannot convert from int to byte. The meaning of this error is now 128 is considered as integer data type because that is out of the range of the byte. But we are trying to store that integer value into byte type. That is the meaning of the error. Now anyway, let us try to execute. Now see the output. Type mismatch cannot convert from int to byte. So internally, now see this program, very interesting part. Within the main method, I declare a variable b as byte type. I am assigning the value 127. Already we have seen that 127 is the within the range of byte data type. Now in the output statement, observe clearly, I am implementing increment operator. We will discuss about the operators concept in detail in the coming videos. But as of now, try to understand, when we write 2 plus symbols before any variable name, that operator is called increment operator. So here I am implementing increment operator for the variable. Then what happens when we implement increment operator is that points to the next number. But here 127 is the last number in the range of byte. But when we implement pre-increment operator or simply increment operator, it is going to point to the next number of 127. Pause the video and try to guess the output of this program. Let us see. The output of this program is the value of b is -128. Now let us analyze what is the reason behind this. See the important point. If we apply increment operator to the upper value, that will point to the starting value again, just like a cyclic manner. See this, you will get the idea easily. The limit of the byte value is -128 to +127 through 0. -128 and it reaches 0, then press 127. When you are trying to increment this 127, that points to the again starting value, that is minus 128. Due to this, if you execute this program, you will get the output minus 128. Now see the program. I am trying to executing this. See the output, B value is minus 128. If we try to initialize byte variable with float value is nothing but a number with fractional value, then it will raise type mismatch error. See the code. In this code, I declare a variable of byte type, but I am assigning a decimal value 20.56. In this case also, it will raise type mismatch error. In this case, the reason is Java treats this value as a double type, but we are assigning this double value to byte type. There is a mismatch between literal and variable. That is what type mismatch error. See the code. Let us execute this. Now see the output. Type mismatch cannot convert double to byte because JVM treats this value as a double type. Next, short data type. It is 2 bytes or 16 bits integer data type. The short contains minimum value of minus 32,768 and a maximum value of 32,767. We can't store any value out of this range. What are the examples we have seen related to byte? You can apply all the points to the short data type also. The keyword short is used to declare variables of short type. Syntax: short is a keyword, space, variable name, assignment, value. Example: short, variable name is number, num, assignment, the value is 10, semicolon. Next one is integer. Integer occupies 4 bytes of memory. The range of the values can be stored as integer data type is this value. This much of wider range values also we can store with help of the int type. When it is required, then only you can declare a variable as int type. Otherwise, the memory will be wasted. Syntax to declare a int type variable is the keyword int. We should not write the complete word integer. The keyword int we must use while declaring the variable of int type. Int space variable name, assignment, the value you want to assign. Example: int space variable name is var, assignment some value. Now see this example. In this example, I stored a value 0, 1, 2, 3 into the int variable. Int num is a variable name 0, 1, 2, 3. Then I want to print the variable value. Pause the video. Try to guess the output of this program. Let us execute this. See the output. Number value is 83. Why we are getting the output 83? What is the reason behind this? Because we are storing the value 0, 1, 2, 3, but we are getting the output 83. If you want to understand the reason for that program, we need to know some points. The integer variable can be stored the integer literal of other number system also. We have 4 number systems. First one is decimal number system. What are the numbers we are using in our daily life? Those numbers belongs to decimal number system. In the decimal number system, we use 10 different digits. Those are 0, 1, 2, 3 up to 9. 10 different digits. That is the reason the base value of decimal number system is 10. Next type of the number system is octal number system. The supported digits in the octal number system are 0 to 7, total 8 digits. That's why the base of this octal number system is 8. This is very important point. If you want to store octal literal values to the integer variable, that octal literal must start with 0. Now observe this program. What is the literal value or what is the constant value we are assigning is 0, 1, 2, 3. This number is started with 0. When any integer value starts with 0, the JVM treats that number belongs to octal number system, not decimal number system. This is important point you need to remember. Next number system is hexadecimal number system. Hexa means 6, decimal means 10. So totally the hexadecimal number system supports 16 different digits and characters. Those are 0 to 9 and A to F. 0 to 9 is one set, and in the second set we have A to F, the letters A to F. Capital A or small a, 2 are valid. A represent 10, B represent 11, C represent 12 and so on. F represent 15. So completely hexadecimal number system supports 16 digits. So the base of the hexadecimal number system is 16. Now the important point is, if you want to store hexadecimal values into integer variable, those literals must start with 0x. The x may be a lowercase x or uppercase x. Next number system is binary number system. It has only two values, zeros and ones. Hence the base of this binary is 2 only. Binary related literals starts with 0b. Now let us analyze why we are getting the output 83 instead of 0, 1, 2, 3 in the previous example. When we are assigning a value starts with 0, the Java understands that is a octal number. Then so internally this octal value is converted into decimal value. That decimal value will be given as output of that program. That is the reason why we are getting 83 as the output of that program. Then how to convert any number system value to decimal number system? This is the common procedure. The rule is, to convert any other number system to decimal number system, we need to multiply the digits of that number system with base value of that particular number system. With this example that will be clear. In this example we are using octal number system. So we need to multiply all the digits with octal number system base value. We know that octal number system base value is 8. See the procedure. Starts with right hand side. Right hand side digit 3. So 3 multiply with, starts with 8 power 0. That is the rule. 8 power 0 into 3 plus, whenever we move from right hand side to left hand side, the power of the 8 must be incremented by 1. See now, 8 power 1 into second digit 2 plus, again 8 power must be incremented by 1. 8 power 2 multiply with next digit plus 8 power 3 multiply with last digit, that is 0. Now calculate all these values. 0 into something 0, 1 into 8 square 64, 2 into 8 power 1 16 and 3 into 1 that is 3. And finally you will get 83. This is actually decimal value. That decimal value will be printed as the output of that program. That is the reason when we execute this program, we are getting 83 instead of 0, 1, 2, 3. I think the point is clear. Now see this example. Try to expect the output of this program. See now the output of this program is 161. Try to evaluate this value and understand why we are getting 161. The clue is, here this value is starts with 0x. So this literal belongs to hexadecimal number system. So you need to convert this hexadecimal number system into decimal by using the same procedure what we discussed. But the change is, in the previous example we have taken octal number system. That is the reason we multiplied the digits with 8 power 0, 8 power 1 and so on. But for this number you need to multiply each and every digit with 16 power 0 into 1. plus 16 power 1 into a. And one more important point. What is a? A value is 10, b value is 11 and so on. Okay. Using that formula, try to evaluate this value. Now see one more example. In this case, I am assigning the value 0b100. Execute this. The output of this program is 4. Now using the same process, try to understand why are we getting this output 4 instead of this one. The clue is this is binary related literal value because it starts with 0b. Next data type is long. Use long type when we need to store wider value than the int type. It occupies 8 bytes of the memory in the computer. So you can observe this much of wider values we can store with help of the long data type. Syntax to create long variable is long is a keyword, variable name, assignment, the value you want to store. The important point is after the value you must write L, that may be a lowercase l, uppercase L, two are valid, but writing the L is compulsory. Then let us try to understand if the literal is not suffixed with capital L or small l, what's happening inside. JVM treats that variable as an int type only. If that variable is treated as integer data type, JVM allots 4 bytes of memory only, but actually long capacity is 8 bytes. So if we are not specifying L, JVM allocates only 4 bytes of memory. See this example. Long variable name is var, assignment some value. Actually this is within the range of long, but even though whenever you are trying to execute this program, you will get an error. Same example. Now execute this program. See the error. The literal, the value we assigned of type int is out of range. Now the reason is, even though we are specifying the keyword long here, if you are not specifying L, this variable is treated as integer type only. Very important point. When you write capital L or small l at the end of the given literal, now this variable var treated as long type variable. In this case, JVM allocates 8 bytes of memory for the var variable. Now execute this. Now you can observe var value is some value what we assigned. I think the point is clear. Check your knowledge, what you learned from this video. Why Java provides 4 different types of integer data types. What is type mismatch error? What will be happened if we write increment operator 127 as value of byte variable? How to store octal, hexadecimal and binary literals? What happens if we miss capital L or small l in long literal value? If this video is useful to you, do subscribe to get more useful videos. Thank you.